Hello, welcome back once again. Today we have this interesting Olympiad mathematics problem. This is an exponential equation, right? So here we'll be solving for the real value of x that will satisfy this equation. 27 to the power of x plus 9 to the power of x is equal to 150. Now let's get started. Before we proceed, take note of this. 27 can be expressed in index power of 3 as 3 to the power of 3. And 9 can be expressed in index power of 3 as 3 to the power of 2. So here, the base there will become 3 to the power of 3, then raised to the power of x, plus this, the base here will become 3 to the power of 2, then raised to the power of x, and this is equal to 150. So let's take note of this property. A to the power of b in bracket to the power of c is same as a to the power of c to the power of b. So with that property, we get 3 to the power of x, then cubed, plus 3 to the power of x, then squared, then this will be equal to 150. So at this point here, we're going to make the following substitutions. We're going to let 3 to the power of x equals y. Okay, now the question is asking for the real value of x. So we all know that x is real if and only if y is greater than 0, right? So, and y is not a complex number, right? So we can see that if y is greater than 0, then x must be real. So therefore, the cubic equation we will derive in terms of y, we must get a solution for y that is greater than 0, right? So here we get y cubed plus y squared. This is equal to 150. So from here we get y cubed plus y squared. This is equal to 125 plus 25, right? Okay, so from here, this is y cubed minus 125 plus y squared minus 25, then this is equal to 0. From here, this is y cubed minus 25 is 5 cubed, then plus y squared minus 25, 125 is 5 cubed, and here 25 is 5 squared, and this is equal to 0. So let's record these following algebraic identities. The difference of two cubes formula. A cubed minus b cubed is equal to a minus b into bracket a squared plus ab plus b squared. And the difference of two squares formula, a squared minus b squared is equal to a minus b multiplied by a plus b. So here we're going to make use of the first identity here. So that will become y minus 5 into bracket y squared plus 5 times y plus 5 squared, which is 25. And here we have plus, so that will become y minus 5 multiplied by y plus 5. And this is equal to 0. So we can see y minus 5 is common, so let's factor that out. So we have y minus 5 into bracket y squared plus 5y plus 25, then plus, we are left with y plus 5 from there. Then this is equal to 0. So from here we get y minus 5 into bracket, this will be y squared plus 5y plus y is 6y plus 25 plus 5 is 30. And this is equal to 0. So we have these two products which is equal to 0. So either y minus 5 is equal to 0 or y squared plus 6y plus 30 is equal to 0. So from here, add 5 to both sides, so we get y is equal to 5. And we can see that this is indeed greater than 0, right? So now, we have this quadratic equation here. So this quadratic equation does not have any real solution because the discriminant is less than 0, right? So the discriminant delta is equal to b squared means 6 squared, which is 36, minus 4ac. 4ac is 4 times 1 times 30, which is 120. We can see obviously this must be less than 0. So there is no real solution for y here. So the only real solution here is y is equal to 5. So now let's recall back. Recall that 3 to the power of x is equal to y, right? So here we get 3 to the power of x is equal to 5. Now let us take note of this. We know that log of a to the power of b then to the base a is just equal to b. So here we're going to log both sides, but the log must be in base 3. So have log of 3 to the power of x to the base 3. This is equal to log of 5 to the base 3. So with this property here, so this will become x. Then x is equal to the log of 5 to the base 3. And this is the only real solution that satisfies the equation. Thank you for watching. Please kindly subscribe to my channel. Also like, comment, and share. Bye-bye.